So one of the issues I've ran into, even though we take off the pop-up blockers and we try to make it as easy to use as possible, it's still sometimes it seems like our browsers will fight us a little bit with the Cengage content. So one of the hints I have, so I'm going to go into week 1 folder here. So if you guys will all log in, I will show you what seems to work for me as an option. So on these, in a lot of cases, if I just click on it, it just kind of says loading content and then jumps back to this page that it's at right here. What you can do to kind of force it to work a little easier is instead of just clicking it, let's hit the preview, and I'm going to do a right click, and I'm going to say open in a new tab. And notice it's going to open in a new tab, loads that content. And so now it will say, here's your preview. These are the kind of the things that are in there. So that may help you to try to right click and click new tab or even a new browser, depending on the size of your, if you have a couple monitors, you can throw it in your own. That's the first tip I have in there for Cengage. Cengage sometimes does some odd things. The other thing I have noticed, because I went into Cengage itself, and Cengage, some of you have already done a couple of the assignments in there, but they are not being sent to Blackboard. So I've got a service tech issue, trouble ticket, whatever with them. So right now, all of the columns have disappeared out of Blackboard that used to be there. So there used to be all the stuff for Cengage was in there. Now I log in and it's gone, even when I try to force a sync through there. So don't panic. I'll get it, and I can actually see those grades. But it's just an oddity that, for whatever reason, Cengage seems to be having some teething issues. That trial, when I go in there, it should actually go till next Monday, according to mine. If you see something different, let me know. And I know I've had at least one student kind of have a weird issue. So I'm going to try to get us through a little quickly today and try to work with a couple of you who have any issues with that. The other question that was brought up was I had one of our students ask about tutoring. And here's what I'm going to say. Cat Center has tutoring available. I've also found really very useful for a lot of classes, even when I was a student, if you do some peer tutoring. In other words, maybe not formally through the Cat Center because I don't know what their scheduling is, but sometimes if you guys can find, half an hour to work together and say drill each other on questions, go through material. And I'm going to try to set up some other resources online that maybe will help that. There is a lot of terminology in this class, and that's probably going to be the hardest thing for most of you is there's a ton of terms, hundreds of terms to try to figure out what they are. And some of them are new, some of them are different, some of them we haven't seen before. So you're gonna have some struggles with that. So formal tutoring at the Cat Center, if you think you're going to struggle at all in here, go out there and apply and figure out what they have for resources for tutoring. I wish I could grab every one of you and do 3 hours of tutoring personally every week. That's just not possible, unfortunately. There's just not enough time in the day to do those kinds of things. Group tutoring, so if I know our lab here is open from 3:30 to 5:30. If you guys meet together as study groups or even online using something like Blackboard, Collaborate, or Teams, that might be a great way to also assist you. I'm always encouraged, and in fact, it's one of the things that made me decide I wanted to teach here at Peru was many hundreds of thousands of years ago, I took accounting courses. And I took them and I kind of understood it a little bit, and I actually did some of that peer tutoring. I tutored other people, and we would get together in kind of groups and try to go through that. And that was that start of, hey, this might be kind of an interesting thing to be able to work with people. And sometimes the weirdest way, even if I didn't understand it that real and I worked it in my head so I could teach it to somebody else, it kind of stuck it in my brain. So it was a really, really good way to go with that. So with Blackboard Collaborate, I can also look at your computer and we can see what's happening with Blackboard. So if you have something weird going on with either Blackboard or with Cengage, we can at least try to figure out a start to it. So a couple of things about Cengage, just as a reminder, you have to use Google Chrome. I know there's a couple Mac users in here. It absolutely hates Safari for whatever reason, and Safari will cause it to have issues and not like the rest of the world. So you cannot use Safari, you cannot use that Internet Explorer, Internet Edge, whatever they're calling it, at any given point. That also seems to break. It seems to be, honestly, between Firefox and Chrome, today I'm going to say Firefox works a little better with it. Tomorrow I could say Chrome, depending on who updates and who updates what at any given point. So that's my quick take on those. I want to do one other thing in class that'll take you 13 seconds. This is only for in class, so if you're online, ignore me for the next 30 seconds. At the very bottom of this folder, you'll see a link popped up that says Week 1 S2. So Week 1, Session 2. If you are an on-campus student sitting in front of one of my computers today, will you go in and click that link and just put in the number of the computer you're at? That's just my attendance sheet for today to say, hey, you're actually here and you're attending class. So bottom of the folder for Week 1 and Week 2. On Blackboard, yes. Yep. Yep. All you need to do is put the number. So if you're a virtual student or you're not in course today, I just want to know who's here today. And that's a quick and easy way to do that. So you'll see those as I go through there. Those will start to pop up. It's just a really quick way to tell who's here and who's not. I wish I could remember everybody, but I can't even remember my own name by the time we're done in here. So open. There we go. So I had a couple of people that have read the book or managed to get in and read it, and they were, oh my God, there's a lot of stuff in here. You're going to go over it, right? Yes. Yes, I am. I need you to read it. I'll talk about it, and then sometimes it's useful to go back and reread it because now you've got a little better idea. And there is a lot of material in here. I can't lie, and there's a lot of new and interesting things, I think, that we're going to talk about. So a couple of things we need to work on is something like a network model. And so we use the term model. That's really just how we create it and how we visualize it. So we have the idea of a network model, and we're going to talk about what those are. We separate it with the idea of physical and logical. And that's where it gets a little crazy. So physical, we talk about where the cables actually run. So if you're in this room, you can see your cables running down the wall. That's the physical. So it describes how the computers, how the parts, how they're interconnected physically. But in a lot of cases, we actually need to think about the logical topology. How is the software interconnected? And so we've got some new things coming out, software as a service, and some of these other things that the physical and the logical are not necessarily the same. So if you think about it even in terms of virtual computers, I have one physical computer that may have 6 virtual computers on it. So how we actually interact with it is the logical. So physical is how it's physically cabled. Logical is that how it actually works. We have a couple of other terms before we get into some of the models. You'll see the term nitrous oxide systems. All right, network operating systems. So you've seen that before. NOS, network operating system. We used to have some differentiation. So it was this operating system wasn't a network system. Now virtually everything is a network operating system. Your phone, your iOS 14 that's coming out is a network operating system. Your Mac OS X 11, 30, so whatever the latest version is, whatever they call it, is a network operating system. Windows 10 is a network operating system. Android is a network operating system. Chrome OS is a network operating system. Linux is a network operating system. There's almost none that are not at this point. So that is kind of that hardware interface to the software, is that network operating system. That is how we access that network, is through that software. It also is generally how the entire computer runs, so other software sets on top of it. And we'll see on this stack here in a little bit what I mean by sets on top of. So the very first network model we're going to look at is something called peer-to-peer. So peer-to-peer, every computer's on the network. There isn't one that's responsible for controlling access. Everybody can kind of see each other, but there's no centralized control. You do have the ability to share out folders and different resources. So you could share a printer. So I could install a printer on this computer, and I could allow you to see it. But there's no centralized way to do that. Everybody has to create those connections and those links individually. Each computer, so we're primarily talking Windows here to start with, each computer has a local account. So there's no centralized control, no centralized administration. That account is only available on that individual computer. Same way with a Mac. If we put the Macs up, we do that same thing in a peer-to-peer network. It's only available in that local group and only those things that are set up. So an example of that's going to look something like this. So we have some resources. These are all local. There isn't anything controlling that. There's no really way to control anything. So it does have some advantages. It's simple. It's cheap. We don't have to buy a server or any hardware. The problem is terms of scale. So if I'm a small office of 5 people, I can probably get by on a peer-to-peer network. I can make it work. If I start scaling that up, suddenly I've got 100 computers. That's really untenable. It's not manageable. You could do it, but you would spend all your time going from each computer, putting in all 99 accounts of the other computer so they could see each other even. It doesn't have any security, and it really is an issue of large installations. It's not going to work. Small installations works great. At your house. Most people at your house, you have a couple computers. You may share out a network-attached device or a storage on a computer. It's a simple little peer-to-peer network, and that works really, really well. The cost, again, is one where we have some differences. So when we start looking at a bigger model, so what we're going to call our client-server model. So in this model, we have a server. Something is serving as kind of a control point. Typically, it's a Windows server. It can be a Linux server. Mac has got a server OS. But the primary thing in business is a Windows server. That server, then, we create what's called a domain. So it's a group of computers, a group of users that we control. And we do that through something called Active Directory. So Active Directory says this is our database. It's got all our users. It's got information about them. It's how we interact. We can actually do things like send out updates to computers. We can send resource limitations or allow resources. So Active Directory is kind of the business model that we use for almost everything we do. Nearly every business you go to that's above 10 people has probably got an Active Directory of some sort. So we need some terms in there. So a client really means any node or anything requesting services or resources from another one. So all of the Windows machines in here are clients to a server that actually sits in that back closet. Typically, clients don't share things directly. Everything goes through a central model. So that server has the ability to, when you create that, you control everything with that model of you are going through a server. So conceptually, this is kind of what it looks like. So here we have everything connecting through the server. Now physically, it may be connected a little differently, but logically, this is what we're looking at. So all of our computers are working through that server. What's wrong with this picture we have already in this book? If I looked at that and I walked into a business and I saw that, what would I immediately see is wrong? What's wrong with it? So it says there's a Windows 7 client and a Windows 8 client. And there's a Mac. What's wrong with a Windows 7 client today? It's outdated. There is no longer any security updates. What's wrong with the Windows 8 client? Even more weirdly outdated. There's no security updates. And so if you're in a network that's got any kind of highly secure data, that should not happen. So Windows 7 should be hopefully gone. Windows 8 should be gone. And we should be Windows 10 or above. The same way with the Mac. If you have a really old Mac, you could have some security issues, but less likely. So that's that model we're looking at. Everything is controlled through a client-server model. So who gets in there? What kind of rules? What kind of resources are available? So there are a lot of different types of server. I speak about the Windows server because we see those most commonly in business. You can also do the same thing with something like Ubuntu, which is a Linux version, or Red Hat, which is another Linux version. There's lots of other models out there. Windows Server just tends to be the largest group of Active Directory controllers. Just kind of the model that's in there. So one of the differences, though, is in terms of pricing. So when we look at advantages and disadvantages, one of the issues is going to be some disadvantages. For one, a server typically has a lot more memory. It typically has a lot more processing capability, more storage capacity. It typically has special hardware. So most servers don't have just one power supply. They have two. That way if one fails, the other one can cut over. They run large groups of hard drives in a RAID array. So in other words, they have a large amount of storage and redundancy. If one hard drive fails, the server doesn't automatically fail. If on your home computer your one drive fails and you only have one drive, guess what happens? Everything you had is lost and gone. So there are some advantages. User credentials assigned from one place, shared resources centrally controlled. Everything is really done and it's very scalable on that server side. So let's talk about cost. Does anybody have any idea, though, about costs on a server? So a computer like what's set in front of you, what do you think something like that's going to run? So you went a little crazy. So $3,200 on you play some video games, I'm guessing. So can I purchase a non-video gaming system? $1,000? Pretty easily, even less probably. A server, if you're really going to buy a server, most likely you're going to spend between $3,000 to $5,000 for an entry-level server. So it's a lot of money. Still doesn't play video games very well because it's not really equipped for that. You can spend hundreds of thousands on a server alone. If you had to go out and buy Microsoft Windows 10 for a home, it's about $100. To move up to the Windows Professional is about $200. And the Professional gives you the ability to join those domains that we've talked about. If you want to buy Windows Server, so the 2019 version, the last quote I got on it for an installation, and it depends on what size of server, and there's some other pricing models. The base version is about $1,000 for just the server license. In addition, you have to have what are called CALs, client access licenses. So in this lab, there's 32 computers. I would have to have 32 client access licenses to be able to touch that server. If I have a printer, it needs to have a client access license. Yeah, there's a small server and rack that we can't even see at this point because there's so much junk in there. It actually runs, yep, it runs a Windows Server version in there. So it's expensive, but it gives you a lot of control over your network. And it makes things possible that wouldn't be able to be possible. So if I had even 32 computers, what I would literally have to do is have the account from one duplicated onto every other one. So each computer would have to have all 32 accounts so that they could communicate for security purposes. Well, that's pretty tedious to sit there and do. And there's a lot of other things. So we'll run some other stuff we're going to talk about eventually called DHCP. We're going to run DNS services, and all kinds of other things on that server. So we're going to see them, and we're going to get to experiment with the one in the back and hopefully not completely destroy the computer lab, because we're going to actually upgrade it to a newer version. What's on there now is really, really ancient and old, and I can't afford a new server, but because of some licensing agreements, I can actually get the latest version of server, and we're going to see if it's going to run on that old hardware. Because the server in there was bought in 2011. So it's kind of ancient, but we'll see if we can make it work. So there's a lot of advantages that we can put on there. So there's even things that we need to talk about how that works. And so services, we know that we can run things like printer icons. We can run all different kinds of data storage. The ways to do that, though, are something called a protocol. Anybody in here a Star Wars fan? What's C-3PO's, what is he called? A protocol droid. He's a language droid. So I always throw that out and see if there's any nerds. But what we have to do is a protocol is really a language. It's the rules that we communicate with, and they have to be the same. The most common thing we use is something called TCP/IP. So Transmission Control Protocol / Internet Protocol. This was developed many, many years ago, back in the middle 70s, and it's evolved. But TCP has a really great advantage. It's open source. In other words, there's not a licensing fee associated with it. So all the manufacturers have now gone together and said, all right, we're all going to use this. Because it wasn't that many years ago that there were other, so Banyan Suites had their own version of a control protocol. And so this has really allowed us to create the internet as it is. If we didn't have that common way to communicate, it would be, well, you guys are all on Windows machines over here, you can communicate. You guys are all on Macs, you have your own internet. But luckily, we've decided that we have something in common. And so what we have in common is something called TCP/IP. You might even call it, and we'll get to that here in a little bit, it's called a stack. You've probably heard, CSI or something, and you're watching it, they talk about, oh my God, the internet stack is down. Well, that's what they're really talking about, is the TCP/IP stack. And so we'll get to that here in a little bit, what it actually is. So this is our model. Here's the internet, and the biggest model of the client server is the internet, because you have clients, people requesting things, and a web server. So here's our guy typing away, and it looks like he's actually even got a Mac, but he's typing away and he's going onto the internet, and he's going to a web server. So Cengage.com is a web server somewhere. It says, all right, we get this page request, we're going to send back that file to you. It is serving up information back to that computer, that client on the internet. Because we have that idea of TCP/IP, you can do that on the Mac. You can do it on a PC. You could do it on a tablet. We've got that common shared platform of how we communicate from one location to another. Now, here's what's kind of interesting. I said in business, most of the control of the domain in all these computers is done with Windows servers. But yet, when I get out onto the World Wide Web, guess what most of the web servers actually are? About 85 to 90%, it's kind of hard to tell, are actually Linux machines running something like Tomcat, Apache, or some of the other ones that are out there for Linux. So internally, we use a ton of Windows. Outside, we use a lot of Linux, and nobody realizes that happens. So you'll see all of these. I know we're kind of overwhelming you with stuff at this point. So what else can we do on here? So client server, we know that web stuff, that's client server. Email is really client server. You don't run your own email server on your own computer. FTP, File Transfer Protocol. How many of you have had 410 already, the web design course? You used FTP to send data to a web server and back. It's a way we send information. Telnet is another way we communicate, and we can actually see the screen. You're going to see remote desktop, and we're going to show you some applications in here very similar with that. Those are all kinds of client-server applications. So there's literally hundreds upon thousands of those out there that are available. So here's an email server. So here we have the sender sending through to his email server. So you're sending to Gmail, and maybe this is coming into the Bobcat email server and sends it back. And so you'll see even more acronyms in there. So we're going to get to all of those, and you will memorize and know all those. What SMTP is, what POP3 or IMAP is, and those different things. But SMTP is the most common way we send email, and now POP3 or IMAP is the most common way we receive email. So it's a set of languages that say this is what's in this file, and I'm sending you this chunk of data. So remote desktop is another one that we use a lot. In most server installations, every server in there does not have a monitor and a keyboard. In fact, I haven't ever seen one that is that way. If you go into Council Bluffs is kind of unique in that there are actually 2 Google data centers. It's the only place in the world where there's 2 Google data centers. Council Bluffs has one on Veterans Highway and then one kind of out by Glen Springs or whatever it is, a little outside of town. They will not tell you exactly how many servers are there. The estimates are somewhere between 500,000 and 1.5 million servers. Those all don't have a keyboard and a mouse. If they need to control them, they use something like remote desktop to get into that server. Here in this lab, there's no monitor hooked up to that server back there, and we use remote desktop. And so that's how we control a lot of those devices. And we can actually remote into essentially any of these computers if you wanted to. We're going to show you some applications later on when you have to support mom and dad who are trying to use a computer that we can come up with some ways to do that also. So this is kind of where I typically would start passing things around, and I can't do that anymore. So it's a little sad and frustrating. But we need to figure out what kind of hardware is in there. So there's pictures in the book. I can point at stuff and say that's what it is. It's a little harder for me to show you this year, and so bear with me here. So any device on the network is called a node. So anything that connects to that network, we typically call a node. So our local area network, so in this case, let's consider this room as a local area network. Everything connects. In this case, we connect through cables, just like those white ones up there. It connects to those network cables, and it all runs back to something called a switch. So we have a 48-port switch in there, and that switch allows us to aggregate all that communications together. And we are physically in what's called a star topology. Everything comes from here back to a single point. We connect through what's called a network interface card, or a NIC. These computers, and most of them now, have that network interface card built in. So you can plug in a network cable. Network interface cards can also be wireless. So if you have a laptop, it's got a wireless network interface card. So the interface card is how we connect to the internet, either physically or through wireless. So this is really a pretty good representation of what our network here looks like. So we have a server, and we have, well, it's not out here because we put this here, but there's a printer we normally have in here that's connected to the network. And we have a switch, so it's got a lot of places for these network jacks to plug into. It aggregates all those things together, and then we control it all through our server. So a little more industrial grade stuff on the left. So Juniper Networks is a case they have. And then some kind of cheaper home stuff all the way down to consumer grade stuff. And in fact, underneath every one of these desks, there is a consumer grade switch, much like on the bottom right, except actually even cheaper. Because when they rebuilt this room 5 years ago, I think it was now, the engineers for the whatever company they hired decided that, hey, we need some floor jacks. And even though we had it set up and told them what they wanted, I need 8 jacks in each pod. They designed it to put 6 in. Hello. So there are actually 6 network jacks, and then there's a switch to connect the other 2 computers. It works. It's not as ideal as I would like it. It's just kind of one of those, really? You came in, you saw what we had set up, and then you said we only needed 24 jacks instead of 32. So that's what we're looking at for hardware. So something like this little guy over here, you can pick up a little switch for your house, $20, $30, $40. A bigger switch like that, a 16 or 24 port, depending on what its capabilities are, you can buy it for $100 or more, anywhere in there. You start getting into some of the bigger blade stuff or the managed switches, the sky's the limit. It's not impossible to spend $10,000 to $20,000 on a single switch. But they have capabilities you probably don't need at your house. So they just did a switch upgrade, and I don't know what the final cost on that, but I think it was probably a couple $100,000 to redo all the switches here in these buildings. And they now do some interesting things, but it's a lot of money. Consumer grade stuff is pretty cheap, but it's not going to work in a business environment when you're sending that much data. It's just not going to stand up. So that's a few of the pieces you're going to see. So here they show you on a laptop, a lot of times the older ones will still have a network jack for like a phone jack, but the newer ones, for space saving, have eliminated that and are entirely wireless. And so here is, if you need an adapter separately, that's what one looks like. They're not very big anymore, but most of the times they're built into the computers to start with. So, some more terms in here. So, our LAN typically has several switches in it. A typical LAN. So here we aggregate all of our traffic back to this closet, and then from this closet it goes to computer services closet. From computer services closet here, it goes back to the administration building before it finally leaves the building. So those connections from this closet to that could be considered a backbone. In other words, it's a very high-speed connection between those 2 spots. And then we daisy chain or link these switches together. So this makes more sense if you see a picture of what we're talking about. So typically, each floor in a building would have a switch or multiple switches, and then we would daisy chain and link those together to connect the entire building. So while we might have gigabit per second connections here from the computer to the switch, we might have spent a little more and we might have a 10 gig or 25 or 40 or even 100 gig connection. So a much faster piece in the backbone between those locations. So typically that's, when we say backbone, that's what we're talking about, is those links that connect switches and hubs and routers and other pieces back there. So this network, they say, has 3 switches, and we can see those. And because we just kind of link them in a configuration this way, we would consider that a hybrid or a star to the first switch, and then a bus from switch to switch. Okay. We have a server that controls this classroom here, yes. It's just going to switches. So it really doesn't ever touch another server on our campus. That server here is only for the purposes here of controlling this classroom. So the backbone is a link from one switch to another in most cases. Yep, it is. So it connects this switch to a switch over here. So back behind the pop machine, there's a room, and there's actually a set of switches and equipment in there. And that's where we connect to that room. That room then connects all the way down through the basement, and there's some fiber between here and the administration building. And so those links from like building to building are backbones, or from data closet to data closet are considered backbones. No, this server is only with this. In fact, our network is just this room. Our network here, because we do some experimenting and testing and we don't want to disrupt anything else on campus, we're somewhat isolated from the rest of the campus. So we have our own router, we've got our network, so it comes in and is fairly isolated from the rest of campus. So we hopefully won't do anything bad. So we also have some other devices. And I think I'm trying to figure out how to do this where I can actually show you what they look like. But you guys kind of have an idea in some cases. So a router is a device that manages traffic between two networks. So at home, you have a router. You've got a box probably from the cable company or from whomever you get your internet service from. And that connection there gets split then either wirelessly or wired to all the computers in your house. That's a router. A router is a little more complicated. It says, hey, I know where to go, I know where I need to go, and I need to find traffic and figure out how I'm going to go from one place to another. When we start going up in scale a little bit, so we get to the industrial size scale, they're not the $50 devices you bought at Walmart or 100 or Best Buy or whatever. So we have to differentiate between the two. So a router figures out a pathway from one spot to the other. A switch really just connects everything together. And so I think what I might do next week is pull some samples out, put them out, and you can at least walk by them, not touch them, trying to figure out how to make it a little more hands-on for you when we can't be hands-on. So a router and a switch do functions that are different on a network. The problem for a lot of us thinking about it is when you get your home router, it's also got a little switch built in. So they've got like a little 4-port switch so you can plug stuff in. A true router really only has the ability to send data. So those little home gateway things you get are trying to do 5 or 6 or 7 things all at once, and they don't do one thing very particularly well. But at home, you're probably okay with that. You don't necessarily need as fast a communication and all the security you have on a business. So for example, here at the top is a home router that then goes into a switch. So for all the communications devices inside, it goes to a switch. Here we have this idea of those combo devices. That's what most people have. And in fact, a lot of your internet companies provide you a combo device that's got wireless, it's got a couple of network connections, promises to clean the kitchen sink and everything else, and they're buying them as cheaply as they possibly can get them. They're not going to do things as well necessarily as a dedicated device, but they're also configured by the vendor, and they're easy to set up and throw in. So we have a router in here. We actually use Peru State College as our internet provider, if you think about it that way. And our internet comes into a router and then goes to a switch, much like the model in the top. But it's a little more advanced router, and we'll get to see that. If nothing else, I'll let you guys walk in one at a time and see it. We can also see the web interface for it at any time. So if I do this, where am I at 0? No, hang on. Forgot my own network organization here. So this is actually the router that sits back in that closet. And so what you're seeing is its dash panel. So we get our internet from the college on this address here, and we distribute it out actually in a couple of different places. And that's just a dash panel on it of what we're looking at in there. So our transmit rate and which port it's on. This one's actually got 8 ports we can configure, and we're only using a couple of them right now. And its receiving rate, what it's getting in from the campus and where it's going. And it's got some interesting features. This is a couple of $100 device. I think it's 300 bucks, something like that. It's not super expensive, but it does what we want it to do. You can actually do some traffic analysis. So each one of those is a computer on our network. What I can tell you by looking at it, notice the majority of the traffic up there in red is on one called 192.168.180.103. That's my instructor station up here. Because I push more data and I do more things with it, you can really quickly see what's on there. But we can actually pull it down by different types of data. We can pull packets and actually do packet captures with it. And we can set up custom routing and all kinds of things. We've got some routing in there for, you haven't seen it in here yet, but I have a tablet that we can actually wander around on the wireless from Peru and actually control the screens and everything in here. And so we've got to have some rules that allow that traffic to make those pathways. So this is kind of a middling range. If I were a small business, this would be probably perfect, something along this scale. It still doesn't have a whole ton of security in it, and so we look at some other devices then for security when we get to that point. What are we on, 25? So here we have the idea of LANs connected by routers. So once we start getting a little further up the scale of security, further up the scale of robustness and reliability, I would probably connect each one of my buildings or even my floors through a router. And that way I can isolate traffic in different areas. What we're seeing though is devices are getting smarter and smarter. We can do a lot of this routing function with some of the newer switches. So when we get to that point, it'll make sense to you. We're just kind of hitting the highlights, so get your brain started. So we talked about a LAN. LAN is a local area network. So here's where we need to sing a song, because we're going to have LANs, MANs, and WANs. Oh, man. So a LAN, small group, computers all connected directly. A MAN tends to be a group of LANs that are connected. A lot of times we also call it a campus area network, even though it may not be a college campus, but here it certainly is. So all of the buildings in this campus would be a metropolitan area network. They're connected. They're in kind of a similar geographic area. We have control over all of them. And so it becomes what we call a metropolitan area network. So if you're in downtown Chicago, you may have several businesses, and they may be a MAN. They may have things all connected so that they're a MAN. The next step up in size, and that's one way to think about this, is size, is a WAN. So once we change from our control to an internet service provider, that's kind of how I call that from a MAN to a WAN. So everything on our campus here is a MAN. Once we have to go to Galaxy Cable or whoever provides that service to us, once we lose control of it, then that becomes a wide area network. And the biggest wide area network then is that internet. So our traffic from here goes all the way back to Lincoln and then jumps into the internet. So that's how we get onto that idea of the internet. We could still have communication from every building to each other building and not have the internet, no connection to the WAN. We would still be able to function and send files, but we wouldn't have that internet connection. So internet is the largest WAN out there. So just to make it more confusing, because we've had enough ands here. So we've got LANs, MANs, WANs, CANs, PANs, and a personal area network. So this is where personal area network starts showing up, is when we connect things like Bluetooth and we create a very small little network with our own stuff. So if I have my phone connected to my computer via Bluetooth, that's really technically kind of like a PAN. I'm able to send data back and forth, but it's really a very small, very tightly geographically limited personal network. If you do that in your car, that would be considered a PAN. So if you hook your Bluetooth to your car and you're playing music, that's really a PAN. You're sending network data, but it doesn't go past the car. So, how's that for confusing? LANs, MANs, WANs, PANs, CANs. Did I get them all? There's a ton of them out there. It's typically the way to think about it is geography. How do I break them down geographically, and how do I break them down with control? So if I have control over it, it's typically and in a small area, it's a LAN. If it's over a couple buildings, that becomes a MAN. Once it hits the internet or out of our control, it becomes a WAN. So at least we make them rhyme. Everybody's going, no, that's a lot of information to remember. So this is an example of that difference. So here's a LAN, and here's a LAN, and then they're connected via a WAN. So once we're outside wide area technology, so from San Francisco to Philadelphia, we have a WAN between those two of them. And in a lot of cases, we don't know the entire connection. So we hand it off and we say, here, internet service provider, I need you to get me from Philadelphia to Chicago, or Philadelphia to LA, or whatever we're going to. We will talk about those in a little more detail, but not today, because you guys' heads are already going to explode at some point fairly quickly. So we talked about that TCP stack. This is it. This is something called the OSI reference model. So eventually we're going to have all 7 layers in there. So there's 7 different layers. I'm going to give you a mnemonic to try to remember it. So a browser and a server, if we look at this, it goes down the stack, sends that data across, and comes back up to that web server. So this is kind of that beginning of that idea. So browser goes to operating system, goes to hardware. It sends it across cables, back to hardware, back to the operating system, and back to whatever application, in this case a web server. So we've gone down the stack and back up this stack. Well, we're going to add some layers to this stack. So, all 7 layers. This will be a final question and probably a midterm question on the fill in the essay ones. So, how do I remember all these layers? That's 7 words I got to remember. Programmers do not throw sausage pizza away. Can you guys all remember that? Programmers do not throw sausage pizza away. That is our way to think about those ideas. So we go from physical all the way to application layer. So it's maybe graphically is a little better way to do it, and maybe that'll make more sense. So this is a way to think about that. So physical, well, that's that cable you plug in or the wire you plug in. Data link and physical are both here. So you can think about those in terms of, that's how I make my connection. The network layer and the transport layer, slightly above that, and we got a lot of acronyms in here to start dealing with. Then we have the session layer above that, the presentation layer and the application layer. Those tend to be these protocols that are a lot of times embedded in our OS. And then we have our application layer at the very top of that. So data is going to go from one side to the other. So I really need an example with 2 of those. It starts at my sending an email. That email goes down through the application, down through the session, down to the transport network, data link, and finally goes to that physical layer and gets sent out. On the opposite side, it comes back in as a dot on a wire and comes back up all the way through that to go back to their email client. I will say this is probably the hardest thing to wrap your head around we are going to do all year, and we're doing it in week 1. After this, it all gets easy. How about that? So once we understand how this works, we're going to be golden. So I'm going to kind of go backwards here because I think it makes more sense to start at the bottom and go up. So excuse me when I do this and I try to go backwards here. So physical layer, I think, is the easiest one to understand. The physical layer says, hey, I've got something I need to send, and I'm going to send bits. And we haven't yet discussed bits yet, but your computer is really dumb. For all the wonderful things it can do, your computer is nothing more than a light switch on the wall. It sends zeros and it sends ones, and that's all it can read and all it can understand. So what you're really sending are bits. A bit is a single 0 or 1. And so it can transmit it as a wave in the air, like a wireless signal, voltage on a wire like what we have in here, or maybe it's light in a fiber optic cable. That's all it can do. So physical, I think, is the easiest thing to understand in there. Data link layer, this is going to be a little weird because I got to go back and forth here. So the data link layer adds something called some frame overhead to that zeros and ones. So weirdly, layer 1 and 2 are both responsible for that physical hardware. So the data link layer says, okay, I'm going to add a piece of information I have and send it with this data that's being sent out on the wire. So there is something inside of every network interface card. And in this case, we get some of that information from it and we send it out. And we'll look at that when we get into this a little more in depth. But this data link layer takes something called a MAC address, or a media access control address, or a hardware address, whatever you want to call it, and it adds it to your information. Every network interface card has a number in it that's unique. And that number tells me who made the network interface card, and it's got a unique number in it. We can see that number on our own computer. So on your computer, normally I would hand some out and you could see them because they're actually in a lot of cases on the device and you can actually see it. But since we can't do that, if you will do this, hit the Windows key and type CMD. So we are going to get a little nerdy early on in the class. So if you will type Windows and CMD and hit enter, you should be at a screen like this one. Is everybody there? All right, so hit the Windows button down here and type CMD for command. And we want to be at a screen that looks like this. This we are going to go to a lot. This is a command line for Windows. Unix has some similar commands. We are going to learn your first command in this environment right now. And I'm going to type IP CONFIG. IP config. So Internet Protocol configuration. So if I type IP config and I just hit enter, it should be behind you also if you can see it. Okay. So IP config, IPCONFIG. And if I just hit enter, it gives me a little information about this computer. And it gives me this address we're going to use later and a default gateway and a couple of other things. But it doesn't give me what I want yet. So I'm going to show you shortcut number 37 you're going to learn in here. If I push the up arrow key, it pops back up the last command I had. So I'm going to do that same command, but I'm going to space and put all in it. So /space or space/all. And when I hit that, it gives me a lot more information. So now it says, all right, here's my host name. Here's my node type. It gives me all this information. And right here, it gives me a physical address. That is a number that is burned directly into that card on the computer. So the first half of this tells me who made the card. The second one is a unique value for each and every card they made. It also looks a little weird because notice it's got letters in my numbers. Does anybody know what that is? No. All right. So we've already said we have bits, which are 0 and 1s, which is base 2. The computer can think in base 2 really easily. As kind of a middling place, the computer can interface very easily with what's called base 16. Well, we don't have 16 letters in our normal number system. So we actually, it's 0 through 9 and A, B, C, D, E, F. And so we'll work on what those numbers mean, but essentially it's a way to cram more information into a smaller space and show it an interface with the computer. So those numbers all have a value based in hexadecimal. So it's another number system. That is that MAC address that is burned permanently into every card and every device. So that is this MAC or MAC address, that's what it is. We can find it that way. If you had a card in your hand or a network device, it's also got one. And it's burned into it somewhere. A lot of times it's stamped right on it. If you want to be cheap, does anybody in here have a cable modem? Do you rent from Spectrum or somebody a cable modem? No, some of you. Okay. They charge you every month like $15 to have that cable modem. It's like, they do? Whatever they charge. I think it's up to $15 a month. You can buy your own. When you buy your own and you go to set it up, you have to call into their service center. And what they're going to ask for is the media access control number that's on the bottom of that cable modem. That's one of the places we'll see it really, really frequently. But this data link layer is where that gets added to our information. So when you send out a message, it gets a lot of other stuff added to it so that message knows where to go, what kind of protocol it is. So we're going to look at one more layer here really quickly. And I want to look at the network layer. So the network layer says, all right, I'm going to add a message onto this. And each one of those messages I send out, I'm going to see if it gets there. And I will also, the other thing I have to do is I divide it up into the appropriate size if it's over a certain size. So we really need to think about what we're actually sending out on that computer network. The computers, we think they're really smart. And they're really, really, really dumb. Because you guys can all count to 10, right? Computer counts to 0, 1. Ah, crap, I got to start over again. So when you send out a message on that computer, your HTML or your email or anything else, it's really just a series of zeros and ones. That's all it's sending out. Well, if all I'm sending out is zeros or ones, how do I even know where the message begins, where it ends, what's in it? And that's really what these layers above this are going to allow us to do, is figure out how we set the limits of it, how we set information in front and back, because all we have are zeros and ones to work with. All we have are zeros and ones to work with. All right. Is everybody's head exploding yet? It is. This is a lot of information. We have a lot of stuff in there. That's why this first week is a couple weeks to kind of start processing all these terms. And because we have to get those basics and those foundations down first, this is probably in some ways the worst week we have. Because you've got so much to try to absorb and read about and think about. We're going to finish up the OSI model then on Monday, and we're going to launch into some other things. But I'll try to see if I can come up with a way you can see some of these things physically and not touch them. It's tough. There is a lot of terminology in here. That's probably the worst thing. So if you guys form a study group or an online study group, going through that terminology is probably the easiest way to get your hands on some of that information and put it in there. Now, Destiny has her own study group, and he'll have to come in and retake the... No. It really is interesting, some of this stuff, but you don't always necessarily see it until you get out of here, and you may have to try to use some of it or understand what's going on. So, make sure you have finished up chapter 1. There is a lot of stuff on Cengage, and I am hoping that the stuff will now show up in the grade book. Again, I've got a ticket request in, but when I go into the grade book now, all of a sudden it doesn't show up. So I have a little glitch in the matrix there, as you might call it. So try right-clicking on these and see if that will open. We have an entire week next week. So next week we're going to hit a lot of pieces in here really, really hard. So I would start reading this weekend to head into chapter 2, because we're also covering parts of chapter 2 in there in this 2-week time frame. But there's the getting the arms wrapped around that terminology. So even reading through the terms, there's a list of terms at the end of the book. Those terms review. We try to provide you with a ton of stuff to try to get that going. The other ones you need to make sure you look at and work through are like these getting started with the live virtual machines, because that's a little more difficult. And there is the lab simulations, and some of those will help you out with understanding these concepts. So there is actually a lot of stuff in here. You're going to have to carve out some time to look at it. But where else are you going to go at this point, right? So on all the simulations and the live virtual machine labs, if you really mess it up, you start over again. They are both set up. You can do unlimited numbers of times. Yep. So you cannot screw them up that badly. Hopefully. No, you can't. You can do them unlimited numbers of times. So that really should give you some pretty good points on there. The simulations, in fact, actually have a video that will go through and show you what you're supposed to do. They talk to you. I will say, if you're doing the simulations and you're listening to them, don't do that late at night if you've eaten too much sugar, because there is a monotone voice attached to that. So it may put you to sleep. It's not the intention of that, is to put you to sleep. So hopefully I can get the Blackboard thing fixed so you'll see your grades moving over there. I'm sure we can. It's just a matter of doing that. Has everybody done the week 1, just so I can see who's here? All right. So you will need to purchase that Cengage now. And again, I think I've got a couple of you that are being able to use it in multiple classes. So make sure you do that as soon as possible. And then I'm going to look at Tim had a weird issue, I think. And then we'll try to figure out where else what we can do. Any questions? Anybody already overwhelmed? No, you guys will do fine. It's just